Welcome to BSc Statistics students. In this class, I explain one problem and the changes in the elements of coefficient matrix A, that is Aij, in the post-optimal analysis. You see the problem. Consider the following LPP. Maximize Z is equal to 10x1 plus 3x2 plus 6x3 plus 5x4. These are the constraints. Subject to the constraints here. And x1, x2, x3, x4 are greater than or equal to 0. Find the ranges of A11, A23 so that new solution remains optimum solution. So I have considered two particular constants, that is the elements of the coefficient matrix A11, A23, which covers both the cases. So I have considered this problem, right? And now I'll explain the solution of the this particular problem. You see, first of all, by introducing the slack variables, etc., and by applying the simplex procedure, because of all constraints are less than or equal to, you have to calculate the final optimum simplex table, that is optimum solution to the given LPP. For this LPP, you have to calculate final optimum solution by using simplex procedure. So after calculating the optimum solution by using the simplex method, we got this particular solution. You see, this particular solution after applying the simplex procedure, the final optimum simplex table and the final optimum solution, it is obtained here in this final optimum simplex table. Okay. If you go and read here, what are the vectors here? y2, y1, y4, which are in the basis. That is x2 corresponding to the variable. The variables are x2, x1, x1, x2, x4. These are the variables in the basis, right? So this is what the solution I'll tell you, and in which here we have indicated that beta 1, beta 2, beta 3, which means the vectors in B inverse. Vectors in B inverse. I'll tell you, I'll explain each and every particular terminology which are required. And now you see the solution of this particular problem. While taking after from the solution, final optimum solution, we can easily we can easily identify the optimum solution of the LPP Z is equal to 643 by 27. That you can observe from the last simplex table. That is simplex table is given here. XB, X2, X1, X4, that is XB1, XB2, XB3 we have considered. 56 by 27, 5 by 3, 5 by 27. I'll show in the final optimum simplex table. This is 56 by 27, 5 by 3 and 5 by 27, and we have written X2, X1, X4 there, and Z is equal to 643 by 27. So these are the values here we have considered. Now from the values you have to calculate and CB, and now the B inverse. Now I take the inverse of B, which is also available in the final optimum simplex table. That beta 1, beta 2, beta 3, in which you have to write each and every element. I have written indicated clearly. Beta 1 1, beta 1 2, beta 1 3, beta 2 1, beta 2 2, beta 2 3. Beta 3 1, beta 3 2, beta 3 3. So this is again I show in the final optimum simplex table. I have written clearly here. This may not, I repeat again, this may not be, need not be in a particular order that you have to calculate. You calculate inverse for the given matrix. And for the given matrix here, B, for the matrix B, for which you have to consider original matrix as 1 0 0, like here the values here, the original values, x2 coefficient 2, here x2 coefficient is not here 0, and x2 coefficient here 1, like that you have to consider the matrix B, and then you have to calculate B inverse. I have explained in the previous one particular class that you have to identify that. And beta 1, beta 2, beta 3 are the inverse B inverse, the vectors of the B inverse, column vectors 5 by 9, 0, minus 1 by 9, minus 5 by 27, 1 by 3, 1 by 27, minus 1 by 9, 0, 2 by 9. So these are the values of beta 1, beta 2, beta 3. That's what we have considered here. We should be very careful about the solution. That B inverse is beta 1, beta 2, beta 3, the column vectors. I have written the values as well, beta 1, 1, 1, 2, 1, 3, etc. And then CB is nothing but cost of the basis matrix, the variables of the basis matrix, x2, x1, x4, the cost 3, 10, 5. x2, the cost, I'll show you the cost again. The cost is for x2 is 3 and x1 is 10 and x4 is 5. So therefore these are the costs here, and after identifying the costs are being written here. CB is equal to 3, 10 and 5. Okay, now the range of A11. First you consider, he was questioned that find the ranges of A11, A23. First of all, range of A11. Now you have to see whether A11 belongs to B or not. In which A11 R is equal to 1, K is equal to 1. So AK belongs to B. So here in this particular value we can observe that XB, X1, we have the vector X1, the K is equal to 1, X1. So X1 belongs to the basis matrix B. Therefore, this is the case A11 belongs to B, basis matrix B. So hence the R is equal to 1 and K is equal to 1, I is equal to 1, 2, 3. What you have to calculate first? First of all, we have to calculate CB beta 1. CB beta 2, CB beta 3, which are required, and then we proceed further to calculate remaining values. What is CB beta 1? CB beta 1 is CB is equal to 3, 10, 5. That is what CB, 3, 10, 5 the vector. And beta 1 is nothing but you see the B inverse matrix here. I have written beta 1, 5 by 9, 0, minus 1 by 9. You multiply these two. That is 3, 10, 5, 5 by 9, 0, minus 1 by 9. You multiply 3 into 5 by 9 plus 10 into 0 plus 5 into minus 1 by 9. First row, that is row and a column multiplication. Then you will get 10 by 9. Like that, calculate CB beta 2. What is beta 2? Minus 5 by 27, 1 by 3, 1 by 27. CB is same, right? So therefore 3, 10, 5 minus 5 by 27, 1 by 3, 1 by 27. You multiply it, 3 into minus 5 by 27 plus 10 into 1 by 3 plus 5 into 1 by 27 will get 80 by 27. Calculate it. Similarly, you calculate CB beta 3. The beta 3 is this, minus 1 by 9, 0, 2 by 9, and CB is the same. You calculate the value, multiply it, and you will get 7 by 9. So like that, you have first of all you calculate CB beta 1, CB beta 2, CB beta 3, etc. How many values you have? You have calculate the values. And then now because of the case, this is case 2, A11 belongs to B, that is ARK belongs to B or AK belongs to B. Then you have to see that two particular things are going to be changed. That is to maintain the feasibility condition and optimality condition. Feasibility is also going to be changed. Optimality is also going to be affected, changed, which means what I say, affected. Therefore, we have to calculate the range of A11 for maintaining the feasibility condition. First of all, feasibility condition, after that optimality. So the change of coefficient A11 is going to be expressed in terms of A11 star is equal to A11 plus delta A11. That is what our consideration, in which the formula will be for delta A11. The range of delta A11 for maintaining the feasibility condition, it is given by the maximum of minus xbi by qi, qi greater than 0, less than or equal to delta A11, less than or equal to minimum of minus xbi by qi, qi is less than 0, for qi is less than 0. So therefore, what you have to calculate, you have to calculate qi, the values of qi. What is the formula of qi? Where qi is equal to beta kk xbi minus beta ik xbk. For I is equal to 1 to 3, k is equal to 1. K is equal to 1, I is equal to 1 to 3, you have to calculate these values. So substitute I is equal to 1, for I is equal to 1, q1 is equal to, here you see, here we have I and here also we have another I. So beta k is 1, so therefore beta 1 xbi minus beta ik, I is 1, k is 1, beta 1 into xb1 xbk xb1. So since beta 11 xb1, beta 11 xb1 minus plus, so this is 0. And I is equal to 2. Then q2, then beta 11 into xbi, that is xb2 minus beta 21, beta ik, beta 21 into xb1 is equal to beta 11 is 5 by 9, xb2 is 5 by 3. Beta 11, the value I have shown the value here. This is beta 11, this is beta 21, this is beta 31. So these are the values which will be required here. And xb1 is 56 by 27, xb2 is 5 by 3, xb3 is 5 by 27. So these are the values we are using now, in which we are calculating q2, phi is equal to 2, beta 11 xb2 minus beta 21 xb1. What is beta 11? 5 by 9, xb2 5 by 3 minus beta 21. Beta 21 is, I have shown that it is 0. You see here, this is beta 21, it is 0. And xb1 is 56 by 27. So therefore final answer is 25 by 27. You calculate it, you will get it. It is greater than 0. And you please mention whether it is greater than or less than 0. So because there are two cases, qi greater than 0 and less than 0. And if I is equal to 3, q3 is equal to beta 11 xb3 minus beta 31 xb1. So I is equal to 3. Therefore, in the formula here, xbi, xb3, beta ik, beta 3, k is equal to 1, beta 31, xb1 equal to 5 by 9 into 5 by 27 minus 1 by 9, 56 by 27. You see the values here, and the final value is 1 by 3. It is also greater than 0. Therefore, to calculate the range of delta A1 for feasibility condition, to maintain the feasibility, the formula is maximum of minus xbi by qi is greater than 0, less than or equal to delta A11, less than or equal to minimum of minus xbi divided by qi less than 0. So for qi greater than 0, because there are two values here, one is 0, leave it, and there are two values which are greater than 0. So therefore you have to calculate minus xbi by q2 minus xbi by q3, which are greater than 0. q2, q3 are greater than 0. So therefore there is no minimum value of that is minus xbi by qi less than 0. Therefore it is infinity, right? So therefore you consider minus xbi by q2, that is minus xbi, that is xb2 here, xb2 by q2, that is xb2 is 5 by 9, minus 5 by 9 divided by q2 is 25 by 7. Like you see, similarly second one, if you consider these two values, and these are the value, maximum of minus 5 by 3 divided by 25 by 7 and minus 5 by 27 divided by 1 by 3, which is less than or equal to delta A11 less than infinity. This is q3 by minus q3 by minus xb3 by q3 greater than 0. So q2, q3 are greater than 0, for which these are the two particular values, and which is nothing but maximum of minus 9 by 5 minus 5 by 9. Maximum value is minus 5 by 9 because of negative values. Maximum value, both are negative, so hence it is minus 5 by 9, less than or equal to delta A11 less than infinity. This is what the right hand side value. There is no qj which is less than 0, qi which is less than 0. So therefore, and this is infinity. So finally, delta A11 limits are lies in between, that the range is minus 5 by 9 to infinity. But we know A11 less than or equal to A11 plus delta A11. This is just by using the common sense we can apply this, and we have to calculate the range of A11. That is, what is A11 is equal to 1. Okay, A11 we are calculating for the maintaining the feasibility condition, the range of A11. The range of A11 is nothing but, now just you add this 1 to the entire this equation, and you will get 1 minus 5 by 9 less than or equal to A11 less than infinity. So therefore less than or equal to, but it is because infinity we are writing less than. So 1 minus 5 by 9 is 4 by 9 less than or equal to A11 less than infinity. So the range of A11 for maintaining the feasibility is 4 by 9 to infinity. That is what our conclusion. Now range of A11 for maintaining optimality condition, optimum solution for optimality. Optimality condition, it is going to be obtained by using the formula, the delta A11, the range of delta A11, the formula is maximum of minus zj minus cj by qj, and qj less greater than 0 and less than or equal to delta ARK less than or equal to minimum of minus zj minus qj by qj, minus zj minus cj by qj where Qj is less than 0. What is Qj? Qj is the formula Zj minus Cj into beta kk minus ykj Cb beta k. Already we have calculated Cb beta k. Zj minus Cj is available. So remaining two values beta kk, beta ykj is also available. So J is equal to 3, 5, 6, 7. Why? Why? Because of net eval. These Qj values are, these net evaluations are going to be calculated for the variables which are not in basis. Already which are in the basis are 1, 2 and 4. Therefore, the remaining values are 3, 5, 6, 7. Right? For optimality condition, it depends on the Zj minus Cj. The net evaluations are calculated for the non-basic variables only. So that is what which are not in the basis. Therefore, you calculate Z3, J is equal to 3. For J is equal to 3, first of all, we calculate one by one J3, 5, 6, 7. J is equal to 3 now. Q3 is equal to Z3 minus C3 multiplied by beta 11 minus Y13 CB beta 1. You substitute here J is equal to 3 and K is equal to 1 here. So therefore, it is Z3 minus C3 into beta 11, K is equal to 1 minus Ykj, that is Y13 because J is 3. Y13 CB beta K. Beta K is 1, beta 1. Where Y13 is equal to minus 22 by 27. I show you the value. Y13 and Z3 minus C3 also I'll show you. In this table, Z3 minus C3 is 82 by 27. Y13 is minus 22 by 27. This is Y11, 12, 13. This is minus 22 by 27. And Zj minus Cj, that is J is equal to 3. Z3 minus C3 is 82 by 27. The corresponding value. Hope you understand clearly. And remaining values we know. And so that we can calculate this now by taking J is equal to 3. Q3 is equal to Z3 minus C3. I have shown that 82 by 27 into beta 11. Already I have shown this particular value. Beta 11 is 5 by 9 minus Y13. Y13 is minus 22 by 27 and CB beta 1 value is 10 by 9. That is also I show it now. CB beta 1. CB beta 1 already we have calculated. CB beta 1 is 10 by 9. CB beta 2 like 80 by 27 etc. So CB beta 1 is 10 by 9. So it is 10 by 9 and therefore this final value is 82 by 27 into 5 by 9 minus of 22 by 27 into CB beta 1 is 10 by 9 is equal to final value is 70 by 27, which is greater than 0. Our objective is whether it is greater than 0 or less than 0, positive or negative. Okay, we have to observe. Similarly, you calculate Zj is equal to 5, Q5 is equal to Z5 minus C5 into beta 11. J is equal to 5, Zj minus Cj, Z5 minus C5 into beta Kk, beta 11 minus Kj, that is Y15 and Cb beta 1. So all the values are known. I'll show you the values of Z5 minus C5 from the table. Z5 minus C5 is 10 by 9. You see, Z1 minus C1, Z2 minus C2, Z3 minus C3, Z4 minus C4, Z5 minus C5. It is 10 by 9. Corresponding value here, Y15, it is 5 by 9. Y11, 12, 13, 14, 15. Y15, 5 by 9. Hope you understand. Like that, similarly, remaining values are going to be observed. So therefore, the values here, J is equal to 5, Q5 is equal to Z5 minus C5 into beta 11 is 10 by 9 into 5 by 9 minus Y15, it is 5 by 9, I have written here, into CB beta 1 is already, I have shown you, 10 by 9, it is equivalent to 0. Like that, J is equal to 6. You have to calculate Z6 minus C6 into beta 11 minus Y16 BCB beta 1. Y16 is minus 5 by 27. So Z6 minus C6 is 80 by 27. That you see, and so that you calculate. We got the value 50 by 27. You calculate this value. Similarly, you also calculate Z is equal to 7. Q7. Z7 minus C7 into beta 11. For all the values which are not in the basis, for J is equal to which are not in the basis, you have to calculate Zj minus, that is Qj. Zj minus Cj into beta Kk minus Ykj Cb beta K. That is what we have to calculate. We have calculated 4 values. J is equal to Q3, J is equal to 3, Q3, Q5, Q6, Q7. The values are 70 by 27, 0, 5 by 50 by 27, 5 by 9. These are the values. Now we have to calculate the range of delta A11 for maintaining the optimality. optimality. The formula is this: maximize maximum of minus Zj minus Cj divided by Qj, Qj greater than 0, and less than equal delta A11 less than equal to minimum of minus Zj minus Cj by Qj, Qj less than 0. There is no less than 0 value here, therefore on right side the value is infinity. This is the maximum value is upper limit. And the maximum value of minus Zj minus Cj by Qj, for Qj greater than 0, there are three values which are greater than 0. 70 by 27, first one, this is 70 by 27, this is Q3, and then this is 0, and then 50 by 27 and 5 by 9. For these three values, Zj minus Cj also required. So for the first value, Z3 minus C3, that is minus 82 by 27 divided by 70 by 27. These are the values of the Zj minus Cj by minus of Zj minus Cj by Qj, Qj greater than 0 values. Minus 82 by 27 divided by 70 by 27, comma minus 80 by 27 divided by 50 by 27, comma minus 7 by 9 divided by 5 by 9. This is Z3, minus of Z3 minus C3 by Q3, minus of Z5 minus Z5, not Z5, Z6, Z6 minus C6 divided by Q6, and minus Z7 minus C7 divided by Q7. These are the three values here, for which if you calculate less than or equal to delta A11 less than infinity, for which if you calculate, simplify these values, we get these values are maximum of minus 41 by 35, minus 8 by 5, minus 7 by 5. So that if you take the maximum amongst these values is minus 41 by 35, this one. This is the maximum value, and less than or equal to delta A1 less than infinity. But we know that A11 less than or equal to A11 plus delta A11. So, but A11 original value is 1. So, therefore, if you add the values here, then you will get the range for A11, that is in the new solution. Therefore, A11 is equal to 1 minus 41 by 35 less than or equal to A11 less than infinity. If you add in 1 for infinity, it's infinity, right? So, this is minus 6 by 5 less than or equal to A11 less than infinity. So, this is what the condition for optimality for A11, the range of A11 for maintaining the optimality. Am I right? Right. So, now if you add feasibility condition as well, what is the feasibility condition for feasibility for that is for A11? A11, the range is range of A11 for feasibility is 4 by 9 less than or equal to A11 less than infinity, and this is optimality is minus 6 by 5 less than or equal to A11 less than infinity. But by combining these two, okay, the range of A11 for maintaining feasibility and optimality condition of the new solution of LPP, it is nothing but this is minus 6 by 5 less than or equal to A11 less than infinity. That is 4 by 9 for maintaining feasibility, minus 6 by 5 for maintaining optimality. By combining these two, it is lies in between minus 6 by 5 less than equal to A11 less than infinity, because it is a negative value minus 6 by 5, that is a positive value. If you consider this particular minus 6 by 5, that is a lesser value, and obviously it lies in between lesser value to infinity, it lies in between 4 by 9 to infinity as well. Therefore, we are combining these two limits for maintaining. We are saying one particular condition for maintaining feasibility and optimality conditions for the new solution of the linear programming problem, right? So, this is what the calculation for A11, the range for calculation of A11. Now, I explain the range of A23. So, you see, first of all, what is the case? A23. A23 means 2. A23, ARK, not 2, 3, right? So, 3, that is the value 3. 3 is going to be considered when it is going to be obtained. It is not in the basis. A23 does not belongs to B, not in the basis. So, therefore, the change of the coefficient matrix A23 is expressed as A23 star is equal to A23 plus delta A23. That is what the usual condition. Then delta ARK for maintaining the optimality, it is nothing but it's given by maximum of minus of Zk minus Ck divided by Cb beta k, and Cb beta k is greater than 0, where is less than or equal to delta ARK is less than or equal to minimum of minus ZK minus of ZK minus CK divided by CB beta K, where CB beta K is less than 0. So now we have calculated CB beta K, CB beta 1, CB beta 2, CB beta 3, right? So CB beta 2 is equal to 80 by 27, Z3 minus C3 is equal to 82 by 27. Since CB beta 2 is 80 by 27 is greater than 0, the range of delta A23, it is nothing but minus of Z3 minus C3 divided by CB beta 2, for which less than or equal to delta A2 is less than infinity. Okay, because only one value we have considered this. Minus Z3 minus C3 is minus of Z3 minus C3. Z3 minus C3 is 82 by 27. So minus of 82 by 27 divided by CB beta 2 is nothing but 80 by 27. Right, less than or equal to delta A23 less than infinity. Therefore, this value is minus 41 by 40 less than or equal to delta A23 less than infinity. But we know A23 is less than or equal to A23 plus delta A23. Therefore, A2 and A23 is equal to 2. Therefore, you add 2 this for the entire equation. Then 2 minus 41 by 40 less than or equal to A23 less than infinity. That is, this is the new value of A23. The range of new value of A23. It's going to be considered the changed value. For discrete changes, A23 is going to be considered here. So therefore, this value is 39 by 40 less than or equal to A23 less than infinity. So therefore, the range of A23 for maintaining the optimality condition of new solution of LPP, it is going to be considered as 39 by 40 less than or equal to A23 less than infinity. Because in case 1, this is the case 1, A23 does not belongs to B. In this particular case, only optimality is going to be affected. That is the reason why we have calculated optimality only, nothing else. So in the case 1, optimality only going to be affected. That is the reason why we have calculated the range of A23 for maintaining the optimality condition. So that is what required solution for in 2 cases. Hope you understand. Thank you so much.